rules of expansion. So when it's division like this, it'll be subtraction in the expanded problem, and with this multiplication here, it'll be addition in the expanded form. So I'm gonna expand this equation. First thing I have to do is distribute the log base 2 to everything in here. So we're gonna start with the 7, and we're gonna start with the parentheses, and it's gonna be log base 2 times 7. And since it's multiplication here, it'll be addition in the parentheses. And with the exponent goes to the front when distributing the log base 2. So it'll be 6 log base 2 times x, and we close the parentheses since it's on top. Now, since it's division, it's going to be subtraction here, and we're going to start a new parentheses and distribute the log base 2 to the 20, and that'll be log base 2 20. And now, since it's multiplication, it'll be addition here, and the exponent goes to the front again, so it'll be 2 log 2 times y, parentheses.
Solve for x when you can get the same base. So first, I'm going to make 64 equal to 8. In order to do that, I need to convert this to 8, and by doing that, I would do 8 squared is equal to 8. And I would keep the exponent and bring it down, 3x plus 5, and I would move this exponent down to get x plus 2. Now the 8's cancel out, and I'm left with 3x plus 5 is equal to, and I have to distribute the 2 to the exponent, 2x plus 4. Now I just solve for x. So subtract 2x, I'm left with x plus 5 is equal to 4. Now subtract 5, now I'm left with x is equal to -1. There we go. Now to prove the answer, you must plug in x and make sure that's correct. So plug in x and you get 8, 3, -1, plus 5 is equal to 64 to the -1 plus 2. Then you're left with 8, and then -3 plus 5 is 2 is equal to 64, and then -1 plus 2 is 1. Solve that, 64 is equal to 64. Therefore, x is -1 is correct.
Okay, so solving for x with different bases, first you have to choose a base, either 3 or 4. For this equation, I'm going to choose 3. So you use it as log with your base of 3, and then take the exponent, leave some space, and put it on the other side of the equal sign. Then you take your other base, 4 to the 2x, and you put it here. Next, you're going to want to move the exponent to the front, so you'll have 2x log of 4 base 3 equals x minus 2. Then you're going to want to move the x's all to one side, so you're going to subtract x here and subtract x here. So you have 2x log of 4 base 3 minus x equals -2. And then you're going to take out x from both terms here. So we'll have x on the outside, 2 log of 4 base 3 minus 1 equals -2. And then to get x by itself, we're going to divide by what's in the parentheses here, and then we'll be left with x equals -2 over 2 log of 4 base 3 minus 1. Okay, so another way to do this problem is by choosing the base of 4. So here you're going to do the same thing, log base of 4, and then leave some space and put the exponent on the other side of the equal sign. Then you're going to move the other base, 3, to the x minus 2, and that's how you start. And then you move the exponent to the front, and since there are two terms, you have to distribute it. So x log of 3 base 4 minus 2 log of 3 base 4 equals 2x. Then you're going to want to move both the x's to one side, so it'll end up being negative 2 log of 3 base 4 equals 2x minus x log of 3 base 4. Then you're going to want to take out the x from both of these terms. So x 2 minus log of 3 base 4, and then equals 2 log of 4, or log of 3 base 4. So then you're going to want to divide by everything in the parentheses to get x by itself. So x will equal negative 2 log of 3 base 4 divided by 2 minus log base 3, or 3 base 4. Why do lumberjacks make such good musicians? Probably because of their natural logarithms.
I'll do algebra. I'll do trig. I'll even do logs and exponentials. But graphing is where I draw the line.
What do you call friends who like math?
I don't know.
Algebros.